Welcome back to part 3 of Tangents in a Circle, homework lesson 20 homework review. And so in the diagram below shown, triangle ABC is isosceles with the measure of AB equal to the measure of CB. Circle M is inscribed in triangle ABC such that it is tangent at points D, E, and F. If the length of BF is twice the length of CF and the perimeter of ABC is 32 inches, then determine the length of BC in inches. Well, okay, let's look at the information we have. We definitely know that AB and BC are the same measure. And then the length of BF is twice the length of CF. So we're going to call CF X. Okay? But again, we know that two tangent segments intersect outside a circle, the segments must be congruent. Therefore, CF is the same measure as CD, which will be X as well. Now, BF is twice as long, therefore 2X. And again, we know that BF is going to be congruent to BE, so that's 2X. But considering now that the measure of BC and the measure of AB are the same, this must also be X. And of course, this will be the same measure too. Therefore, we can find that the perimeter, we're told the perimeter is going to be 32 inches. We can add them all up. We'll have 2x plus 2x plus x plus x plus x means in this case, so 2x plus 2x plus x plus x plus x plus x equals 32, because 4 single x is there. That means we have 8x equals 32. Divide both sides by 8, x equals 4. And so, therefore, we know that in this case, CF must be 4. And BF must be 2 times 4, which is 8. The question now is asking, determine the length of BC in inches. Well, BC is going to be the sum of BF plus CF. So BC equals CF plus BF, which means BC is equal to 4 plus 8, which means BC is equal to 12 inches. There goes question number 6. So this is how we set up this idea, because it didn't seem like a lot of information there, but we did know that the side AB was equal to measure side BC. So with the two parts, in this case, if we knew that BC was 3x, then AB had to be 3x as well too. And if BE was 2x, then AE had to be 1x. So that's how you kind of fill in the information there. All right. Let's move on to our next question. Number 7. All right, number 7. This is the last one we have here for the homework assignment. In circle M, segment AB is tangent to a circle at point C. So C is the point of tangency. AB has endpoints such that AM is perpendicular to BM. Well, that gives us a right angle because perpendicular lines form right angles. AC is 9 and BC is 4. And we want to find the measure of the radius, and that would be the same measure as MC. Now, here's the funny thing. We have seen problems like this before in a different type of situation. So even though we're doing with circles, when we talk about here, this is actually a problem that deals with drawing an altitude to the hypotenuse of a right triangle. And here's A, M, here's B, and here's C. And so the idea here is that we have a projection of AC, we have the altitude of MC, and the second projection of CB. So we have a portion here of AC over CM equals CM over BC. Okay, this is actually something from before on having to do with the lesson we did on when a altitude is drawn to the hypotenuse of a right triangle. We know the triangles are formed are similar to each other as to the original large triangle, and in this case that the sides create proportions, this being one of them. So here, again, if you remember, this is projection 1 over altitude equals altitude over projection 2, where the altitude is the mean proportional between the two projections. Well, so we got 9 over x equals x over 4, and we cross multiply to get x squared equals 36. We'll take the square root of both sides, and we get x equals to 6. Therefore, if CM is equal to 6, that is the same measure as the radius of the circle, because CM is the radius of the circle. So therefore, the radius of the circle is 6 units. Okay, and so yeah, so again, we see here that we are using a different idea from geometry from before being applied into the circle problem. So we're seeing a lot of just kind of mixing of different ideas. So don't expect that your problems will just be single topic problems. A lot of our work will be kind of blended together. So you really need to know not just one idea in geometry, but all the things we cover. So I hope this is helpful to you guys. And let me know if there are any other videos you want me to work on, topics and such. If you'd like me to do a video on what happens when we draw an altitude to the hypotenuse right triangle, I can do that as well too. Anything you guys want to cover, please leave in the comment section below. I appreciate all you guys are watching. Please, if you found this video helpful, leave a like and make sure to subscribe to the channel and hit that bell for notifications so when any new videos are posted onto the website, to the YouTube channel. Thank you so much, and I look forward to presenting the next video to you guys. Take care and be safe.